all the audio is working. I don't want it to be like last year where the modifier uh, session, the audio was just not there. So everything should be here this time. Okay,
Nice.
it's time. Sweet.
Woo!
Woo! Make sure everything's going. Good. Here we go. Okay. Hello, everybody. Can everyone on the stream see me right? And also the Shader Night uh, slides and everything?
Yes, we good.
Yep.
Yes. Okay, good. Bring this around. Hello.
Hello. How's it going?
Okay, we're about to start now. Okay. Yeah, so welcome everybody to the next session of GAC. This is a big one for all that you've shown up. Thank you so much for being here. This is our famous Shader Nights. And some applause. Thank you. Yeah, so this is gonna be a really fun one. Briefly, I'm gonna just say we're gonna go through the theory behind like making shaders and everything, and then make our own little shader at the end. It'll be pretty fun, and I'll explain like the prerequisites to doing that. Make sure we all have our scene set up and everything in Unity. So, first, some announcements for GAC. Our GACtober is finished now. So, all our submissions have been submitted, and we're going to have our raffle at the end of today's session, and the winner will receive a $25 gift card of choice. And I believe, Anya, you're going to provide that link to the wheel to spin, right?
Yeah, and then the winner just hits me up.
Yeah, and the winner will hit up Anya on
Easy.
Discord or in person, wherever you can find her. And then, yeah, you can choose what
Yeah,
kind of...
hits me first.
Say again?
Hit me. Just find me and hit me, and that's how you get the money.
Yes.
It's a
Yeah,
lore drop. It's a loot drop.
exactly. You hit them and then stuff comes out. Yeah. And then mystery prize, we're gonna decide who wins this we're gonna look through our GACtober submissions, and we're gonna decide as GAC who's gonna win this. This will be a prize decided at a later date, so just keep in tune for that. Stay tuned for that. Today's agenda will be as follows. We are going to be introduced to technical art. It's a very fun avenue. It's very brief because we're mostly going to be talking about shaders, which is a branch of technical branch of technical art. We're going to talk about what are shaders, the kind of shaders we see in games that we already know and love. I'm going to say that shaders are for everyone and explain why. I'm going to talk about node systems for shaders, the resources that you can look out to that I know of for making your shaders and just exploring different ones online. And then it's going to be our practical component where we're going to create our first ever shader together, right? So before we begin, I would like anyone who wants to participate in this to open a Unity URP project. And then we're going to, as you can see here, we're going to click on the package manager under the window tab, search for shader graph, and then install it, right? We'll be revisiting this project in a little bit afterwards to create a first shader together. And once we start, I'm going to also bring this slide back up. This is kind of how we set up our Unity scene to start making shaders with the shader graph. So yeah, let's dive in. Technical art. Technical art is my favorite aspect of making 3D in general, just because it's so there's so much you can do beyond like the default texturing things by hand. There's so much you can scale it infinitely compared to doing things all by hand. Tech art, as I was saying, is the bridge between artistry and programming and 3D graphics. It leverages the strengths of computers through procedural art that saves time for the artist and looks good. That's what's important. That's the niche that I find myself working in through most of my work. And this is just, I did not make this. This is a shader that I really like, and it just came out on a website called Shader Toy. And I'll explain what Shader Toy is later in the resources section of this session, but that's what you can do with technical art. And specifically, shaders are what we're going to be talking about mostly, which shaders are pretty much everything you see on the screen. Shaders are everywhere. All the visuals in your game, in the games you play or make, are based on computer graphic shaders. The shaders communicate with your GPU on how it's supposed to render the scene data to the screen. And shaders dramatically influence the way your game looks and feels. And as you can see here on the right side, these are just some more shaders from the amazing website Shader Toy. You can see the top one is like this pretty little refracting ball. And then at the bottom is our, like this is a Journey. And that's like one of my favorite games. But that's made in Shader Toy as like a fan art. So there are two main shaders that we edit. There are the vertex shader and the fragment shader. This is, so the fragment shader is our geometry, right? So whatever you see in 3D at the very low level is going to be the vertices first. And we can, by default, your vertex shader will already just create the mesh that you feed it, but then we can edit our mesh procedurally through using noises and displacement and just moving things around. And then our fragment shader is pretty much the paint on top of our vertex shader, where it adds like the shading, the lighting, the colors from whatever light sources or post-processing effects you add. Right? Most of your shader work is here. This is very specific for like terrain generation or geometry nodes in Blender, which that is, you know, its own little niche. Roles of shaders, as I'll reiterate, is lighting your 3D and 2D models in your scene, right? The main shaders that you would find in the games you play or the games you'll make are toon shaders, PBR shaders, and NPR shaders, right? So toon shading is sort of like the banded look you see here. I'll be talking about games that look like it soon in this session. You have the PBR shading, which is like highly realistic looking, right? As you can see right here, this is like a rusted metal ball, right? And then NPR shading, which is like a mixture between the two. It's, yeah?
Are you going to be sharing these slides? I want a picture of that ball.
Yes, I can share the slides after this. I'll send the link.
Thank you.
And then NPR shading is, I actually didn't say what PBR was. It's photo-based, or physically based rendering, so it looks realistic, right? And then NPR is non-photo physically realistic, or something like that. Or it's stylized, but it still uses the graphic elements of PBR, like metallic and shininess. Shaders also can do particles and VFX, and then procedural mesh and terrain generation, and much, much, much more. Really quick, there's some common shading models that are used in like computer graphics. This is very technical. It's me just nerding out about it. We have Lambert Wrap, Ornear, Burley, and Toon. And then for specular, which is like the highlight points of like whatever light source you see, you have the Schlick GXX, or GGX, Blinn, Phong, Toon, and Disabled, right? So most engines, this is a tangent, most engines use Lambert, and that's stupid because Lambert is really old. It's like a calculation, like a series of calculations from 1760, the year, right? Before computers were invented. So the fact that modern computers use it is only because it's a little more performant than the other ones, but some of the best looking games visually use Burley or Ornear, not Lambert. But also, Godot uses all of these, right? But then in Unreal and Unity, you cannot change them from Lambert, which is a really big thumbs down. Thank you. And then in PBR and NPR specifically, you have your common shader texture types. You have the albedo, which is like the color of whatever model you're looking at. So like this table is like a lighter brownish color, and then that chair is blue, right? So that's like the color without any lighting bias. Normals are the most interesting type of texture you can use because it takes the light data from your the world, and then it uses the RGB channels to kind of fake detail. and it's really satisfying to see it this way, and I'll showcase it in a sec. Roughness is like the amount of shininess surfaces have. Like the carpet would be 0 roughness, or it would be 1 roughness for full, and then something like this screen is shiny if you look from an angle, so that would be like closer to 0 for roughness. Ambient occlusion is the darker areas around areas of your models which would be occluded from light, so any sort of crevice or crack would have ambient occlusion, so it'd be darker, right? And then metalness or metallic it's just either on or off, so 1 or 0, white or black. It's pretty much just if things are metallic or not. And you can see here, this is a really cool texture I found to display online, or to showcase to you all from online. You can see here there are 4 channels being used. You have the base color here, the albedo, the normals here. This one's ambient occlusion, and this one's roughness, right? And there's no metallic because this is not a metallic surface. But you can see here, especially near the edges, you get some fine details that you would not normally get if you were just to use this flat color texture, right? So once you combine all these together, you can get high resolution textures and shaded models like this. Right? So shaders in the games we love. This is a little biased because these are the games I kind of like to talk about when I'm talking about shaders. So first one for cell shading, which is the first one we talked about, was Legend of Zelda Breath of the Wild. This is a pretty standard example of this because they do it so well. You can see on Link here, you have the sharp bands of light. You see the sharp whiter colors here, and then the darker blacker colors here. Come right in. That give the model its depth, it gives its depth without looking ugly realistic, right? Those
None of this is useful to me.
That's all.
You want to see some pseudocode in action?
No, I hate coding. I don't know why I'm in this program.
Just turn you down. There you go. So the toon shader is beautiful because you can get shaded looks like this, but those bands make it look like it's still like an anime kind of a hand-drawn look, right? But it's still being rendered in 3D, right? And then very highlighted areas, you see that's like the specular highlights. Those are usually going to be white, as well as the outline of Link. Usually there's some areas that are really, really white as well. That's also a rim outline of the shader. So toon cell shading imitates a hand-drawn 2D animated look and leveraging 3D graphics. And you can find games that use this today a lot more. Journey is one of my favorite atmospheric art games. There's not really much to do except walk, but that's the part of it I love. It's like a storybook or like a dream you can just walk through, right? This art style is kind of like that NPR look where it uses PBR workflows, but it does it stylized, right? So you can see this beautiful shiny sand here, and it has like this bumpiness, but it looks really pretty and dreamlike. It doesn't look realistic. And I like how this game also has like really good post-processing atmosphere, excellent color choices, and just really good hand-drawn elements, right? You can see like the clothing on your characters, nice and flashy colors, and it's all like hand-drawn and everything. And yeah, finally, we have Elden Ring. And this is a perfect example of the PBR workflow done in a great stylized way. Right, so everything looks really realistic, but it's in a fantasy world. So you get the strengths of PBR realism, but you can have it in such dramatic settings, right? Procedural terrain generation is very heavily used here due to the size of this game, which that's tapping into the vertex shader of things. This game got me really interested in environment art in general because it was just so incredible to see a spot in the world and you can just walk to it. I'm like, that's the coolest thing. I know it's been done before, but this was my first exposure to it. And this is cool, right? But how do you start doing this, right? Nodes. This is the part where I say everyone can make cool shaders. right? Nodes are the, as I'll explain here, the block coding used to make technical art. They are supported in most 3D game engines and are visually inviting for any artist to use because it's all, you can see everything in real time. You don't have to imagine things or constantly like render it to the screen through your shaders code. Shader materials have outputs that we can input our nodes into to build our shader through. Welcome. Node editors are the way that you approach doing your shaders and whatnot. So the main ones I've used in my experience has been Substance Designer, Unreal Engine Material Editor, Godot Visual Shaders, Blender Shaders / Geometry Nodes, and the Unity Shader Graph, which is, I highlighted it because that's what we're going to be using today for our little cell shader we're going to make. So Substance Designer is pretty much the place to make procedural textures, right? You can do other things like you can do particle effects, VFX, flipbook textures, things like that. But the main use here is to make tileable textures that scale indefinitely, and everything is nodes. It's the most node-y app. It's literally made to use nodes. Unreal is a little different. It's a place where this is a little more upper year, but you would take those textures that you make in Substance Designer, and then you would take them and then plug them into your master material. This is like the material of materials, right? Welcome in. Are you for the session?
Yeah.
Yeah, welcome. Find the seats. So, Unreal Shader Editor, you're not really going to make the textures in here. You're going to take your textures, plug them in all together to get that PBR or NPR workflow working. And I can show you as an example. This is the master material I worked on last year for our team's game, Stormhammer. Woo! Yeah, Stormhammer.
So
And
cool, man.
thank you. It was supposed to be just really catchy, you know? And you see here, it's hard to see, but these are all the different channels I talked about. Like, there's the base color, the specular, the normals, the roughness, the metallic, all here. And you can see these are the different materials that you can get from that. I plugged in the textures that I made in Substance Designer. And then you can see here I can get this shiny ball here, this like carpet, gold texture, the stone,
It's not a basketball.
marble. It's not.
Wow.
I just put, so there's like banners up here, you can't see them, and those are the textures that are applied to this ball here. Yeah, unfortunately it's not a basketball, but it does look like one.
You should make Stormhammer play basketball.
True, and then like, I have one of these as like the net that you just scored in there, you know?
Winning game.
Should dunk on your boy.
Yeah, it's Duncan Cron. Yeah, facts. Yeah, and so that's the higher level of materials and shaders. Godot, I did this during the summer for one of the work placements I did. It's similar, but I can do a lot more like custom stuff in here. That's more for like mobile and hardware. Here is an example of, we worked on a Plinko machine, and I just plugged in some base color, some scale, some scrolling LEDs, light maps, normal maps, and then I got a result like this. Right, so it's a shiny Plinko machine. And shaders are cool because you can do animations with it without costing extra CPU performance. It's all done on the GPU. You can see here, those LEDs are scrolling. And all I did was, over time, I just scrolled them along the texture within, let me just play them again, within the node or the visual shader editor, and you get results like this. It's really fun. And next is Blender shader / geometry nodes. This is a setup I did. You don't have to, by the way, you don't have to worry about what I did here. I just didn't tell you what I did. This is my vertex colors setup, so I can procedurally add colors to my models at the vertex level versus the texture level, which helps me create my models quicker for the blockout phase. As you can see here, This was one of the blockouts I did for the models this year for our game. And this is all done with vertex colors, so this is all being applied to the vertex shader, right? And this is good. There are a few reasons why you do this, but I don't have the time to explain it exactly today. And then finally is our Unity shader graph. This is what we're going to be using today for our little workshop. This is the setup I did for the shader we're going to work on. Don't worry, I'll walk you all through it, whoever's going to participate. And that will get us a result looking like this. So you can see here, it's a little stylized toon shader. And it has multiple bands here, and then it has some noisiness on it as well, right? And so we're going to be creating some parameters as well, which parameters are editable options that enables you to tweak exactly how these shaders are going to look. PSA, don't do your nodes unorganized like I did. This is just a return.
Is that right? Is that the TA for the visual narrative?
Yes.
Yep. Oh, yeah.
This was a gag from last year's shader night, and I just thought I had to bring it back.
Yep.
It was so good. Yeah, so this is from my second year. It's just a mess. There's no frames and like organization. Don't do this, because in the future when you want to go back and explore what you did before, you'll not be able to figure it out.
And you'll look like confused Ridger.
Yeah, you'll look like confused Ridger, right? So you want to organize your nodes like you would with any other sort of project you're working on. Resources, real quick. I think my time is limited. The classes starts at 5:10, correct? Okay. So Shader Toy. A lot of the shaders that I was showing you are from Shader Toy. You can just explore different shaders online. All you type in is shadertoy.com. You should find this as like one of the first few links. And the coolest part is it's like you can see the code and everything. And you could, if you wanted to, you could scroll through and see exactly what happens to get this result. And then you could even tweak little numbers and values here and get substantially different results on the shader itself. So that's what it looks like full screen. That's all done with code. There's not a single bit of hand modeling this in Blender or anything. That is just code, right? That's very beyond even me. This is also a cool little effect I saw on Shader Toy. A lot of the shaders you'll see on Shader Toy are animated, so you can see that they move and are interactive. You can click around and everything. So I recommend Shader Toy. Save it on your bookmarks, as well as NoClip. NoClip is a very fun tool that you can use to explore older games, whether it's NES, or not NES, that's a little too old, any 3D game, like N64, GameCube, Wii, PS1, PS2, PS3, PC. And you can explore it, fly around like in Unity, and you can enable or disable certain render properties like the vertex colors, the textures, everything. Yeah.
Can I add something for the node editor stuff?
Yeah.
Just, by the way, the Blender node shaders are not natively able to be used in Engine, so if you're using it on your workflow on your models, don't think that it's going to be able to be used in Unity or Unreal.
Yes, that's also really important. All of these, let me just go back. All of these do not transfer over to each other unless you have specific add-ons, which I do not use. They are all their own separate node systems that you have to learn independently.
Except for Designer.
Except Designer, because you're just exporting the textures, and then you use those textures in the other node editors, right? But yeah, just keep that in mind. So NoClip, this is obviously N64, or this is the DS version of Mario 64. You can fly around and everything. This is Luigi's Haunted Mansion. I thought it was really cool. You could just go in and see everything super close. You can see how they did the shaders and how they did the computer graphics in here. And then this is just part of Dark Souls 1. I just kind of found a cool area to take a picture of. There's so many games you can explore here. It's so fun. And then finally, this is a YouTuber that I absolutely adore. Thank you, Ethan. This is Acerola. And I'd say this is the go-to place for anything shaders, or just anything game dev, but mostly computer graphics shaders. He covers a huge variety. topics that you might eventually come across when you're making your games in your GDW classes. So I highly recommend him. A lot of like his Kuwahara filter video was something that I adored so much. It helped me with getting so many results in my games. I highly recommend checking out this channel. Very good for computer graphics. Enough talk. Let's get shading. So, we're gonna make this banded shader, as I showed earlier. And if we have time, we're gonna add this noisy effect to it as well. So, once again, before we begin, if you're participating, open up your Unreal project. Make sure it's URP 3D, so Universal 3D Core. And then once you open it, you're gonna have to go into Window and then Package Manager, and then type in Shader, and then install Shader Graph. Right. So I'm just gonna let that sit for a second, and I'm just gonna walk down to see how things are gonna go with that.
I'm winning.
Yes, and you're gonna make. We're gonna get to that next.
You're not gonna start shading?
Oh, like where you or what did you? I didn't.
Same reason I did.
I didn't have to. You know, like out of just on Monday.
Yeah, well, I mean, I'm sure I can figure it out because like I know how to use nodes and stuff. So shader graph like would make sense. But like it's tech art. We tend to not do tech art. So.
Real. Yeah, one of our programmers is doing all that for us. So.
All of our programmers took CD, so
Yeah.
they handle all that stuff for us.
Yeah. Oh. Luckily all of us besides one person is in CD.
Who's not doing one? That makes sense.
Yeah. Is it
This guy's an idiot. Guys, Cecily. Bro, I went to Luke, Jaden, all of them. Me and Jaden went to go pick up Luke, and we saw someone in the front window. And we were like, yeah, Luke's one.
Or is that just
because that's where he's watching it.
Oh.
So we were taking pictures of like the outline of him.
Why?
And then we were like, yo, we saw you, and then he's like, no, that was my dad.
Bro, imagine if it was like his mom or something.
Oh, I'd say.
Yeah, no, it was Luke's
Like you
dad.
guys are weirdos.
So
It's like,
have you
oh,
downloaded
my
Shader
friend is
Graph?
probably in the bathroom. I'm gonna take pictures.
Yeah, it was funny until it was his dad.
And package.
That's crazy.
Type in shader. And ideally, the newer versions of Unity, nothing like older. This one should work. We have it for
No, I'm gonna follow
You see what you're doing, huh?
Yes.
You're gonna follow on it.
Nice.
Are you gonna follow on it?
Oh, I'm gonna try. I'm
Excellent.
gonna be good. See what's
Nice.
up.
Okay.
know what to do next.
That's what we're gonna do next. We're all gonna work on this together.
Oh, it's just like tips and stuff.
Got shader graph installed?
Yeah.
Great.
Oh, wait,
Okay.
multitask.
So now we're gonna get started. We have about 29 minutes to do this, so we should be able to get it done in time. And let's get to it. So, woo! Okay, I already have my project open, just because I wanted to save time from it opening. So this is the basic setup of what it's gonna look like, and I guess I can quickly explain it, and annotate it before we even start. Let me just open my PureRef. Also, pro tip, PureRef, if Gavin didn't put you on it already, I'm gonna put you on it. PureRef is the goated reference software, and it just goes anywhere on your screen, and you can just, it's like infinitely tiling, and it's expandable. So I recommend using it. Wait, oops, it's the wrong one. Open recent.
See how much he had open there, guys? PureRef is the best.
See, look at this. So many different, and I'm organizing it too. I'm putting listing what it is as well. So here, is the shader. I add, this is, so, oops. What is it? D. This part right here, we're not going to worry about that yet. That is, if we have time, we can add the noisiness effect to it. So what we're going to worry about is everything kind of up here for now. So starting off, we're going to be creating, if we go into our Unity, this is a tomato from my modeling class. I'm going to go to make a new scene here. So create organization is key. Here's GAC. I'm going to create a scene. Shader. So here's my new scene. First thing I'm going to do, right click, create. We are going to create. If you go down, I hope it's the same for you. We're going to go to shader graph right here. Do we all see that? It's near the top for me. So create shader graph. You see that?
Nope.
No, really?
Did you install it?
Yes.
You install it.
You're in the right Unity version. The new URB.
Oh,
Is-
got it.
You got it? Perfect. So shader graph, go over to URP, unlit shader graph. So create shader graph, URP, unlit shader graph. And then we're going to click. We're going to quickly call this toon shading. My fans are revving up. Excellent. So now we're going to right click again, create material, and I'm going to call that toon shader as well. Right? And by default, you can also right click in your hierarchy right here and just drop in a few primitive assets. Like I'm going to drop in a sphere, drop in a capsule, drop in a maybe cylinder, and I'm just going to kind of move those around a bit like so. So by default, if I have these shapes here, if I drag and drop the toon shader on there, you can see it's looking kind of the same, just white. Right? And the reason is because we haven't applied our shader graph to the material yet. So to do that, simply you're going to drag and drop the shader graph onto the material like that. And all those materials or those objects you put in the scene with the material that added should turn a gray color like this. And that's because we have not, if we double click on the shader graph here, we're going to have this tab open right here. If you want to full screen it, it's shift spacebar. So shift spacebar to go in and out of this new tab that's appeared. So this is our shading window. There's nothing here. It's just color. So that's why our model's looking the way it does. And so the first thing we need to figure out is how are we going to take our model's primarily getting its information from the sun or from what like any light source, but specifically in this case it's the sun. So we need to figure out how to capture that data. In the reference here, you can see that there is a node called main light direction. And that's pretty much taking wherever the sunlight is in the world, the vector direction, so wherever it's pointing towards, that's the value, that's the vector value that we're getting from that. And then normal vector is your objects all have normal vectors, and they're, as I showed earlier, represented by that purple RGB color channel, right? The main thing that is important is that the dot product will calculate those two directions. If they're going the same direction, those two vectors, it will be lit as a value of 1. You'll see it as 1, which 1 will be represented as white. And then if that vector is in the opposite direction, it'll be represented as -1. And if it's at an angle, 9-degree angle, it'll be 0, right? So that's the theory. Practically, you're just going to see this result. If we spacebar, main light direction. Hopefully, if you have a newer version, this is a node that is in your project. If not, then there's kind of no other way to do this right now, unless you open a new Unity project. But main light direction, and then you're gonna type in, what was it? Is it normal? Oops. Normal vector. Right? You can see here, there's this ball. And if I literally just plug this ball in to base color and then click Save Asset at the top here, and I go back to the scene, all those models are going to be looking funky. And those values you see are the direction. That direction displayed as a RGB value. The main thing is when we dot product, so if we add a click spacebar, add dot product. Dot product, I can't tell you exactly what it's doing because I'm not proficient enough to understand exactly, but I do know that it's calculating that 1 or -1, 1 value. You can see here that you get that shaded look here on the model. And if you click, if you click Save Asset, then it's going to update in your scene. Okay? So now you can see that there is this shaded value, but it's looking like it's the opposite direction of the sunlight, and that's because the way the dot product is calculating. And to fix that, there are a few ways to do it, but the way I am doing it for this specifically is we're going to create a remap. So just type in remap, say spacebar, type remap, double click, add the output to the top here, and then plug that in. So we're going to change these values here. As I said, we know that our range right now, it's from -1 to 1, right? That's the -1 is the lowest value, and then 1 is the highest. And so we want to remap that so that the -1 is equal to 1, and then the y value is equal to 0. So that's kind of just inverting that lighting that you see in the project, or in the shader. And so if we connect all that and click Save Asset, it's looking a little more like what we'd expect, right? You see that wherever the main light in their scene is rotated, direction line. Wherever it's rotated, if I change that to global, it will adjust on the shader as well. So, back into our toon shader. We gotta add that banded look that we're going for a classical toon shader, right? And so we're gonna ignore this part here for now, including this multiply. We're gonna pretend that this is plugged in straight in to divide here. Now we're going to divide up our model, or our shaded model bands, into like more values that we can work with, and then floor it. What flooring does is it rounds the value to the nearest whole number, right? And so what we can do is we can divide up our values so that we can get multiple whole numbers within this range of 0 to 1, and then floor it to get those incremental gradients, right? So the most important thing here is that we're just going to copy this layout here. So I'm going to walk you through that. We're going to add a divide. Right, here's a divide. Plug that in like so. And then this is, now I'm gonna introduce you to parameters. So as I touched on it a little bit, parameters are the way for your model to customize your shader within the editor versus within the shader graph always. So on the left here, you should see this tab here empty. If not on this side, it'll be on the other side. You're gonna click this plus, and you're going to add a float. Call that bands. So those are bands. I'm gonna click on it. I'm going to set its default value to 0.49. It's very specific because that amount worked for getting the ideal result by default. So just do 0.49 in your bands parameter here. Drag that in. So now you have your bands parameter. And if I put that in here, you'll see it just changes it a little bit. Now, I create a floor. So spacebar, type in floor. So we're going to take our divide here, plug that into floor, and then plug that into base color. And so now, if we go back here to our scene, you'll see we're almost there. We have these solid chunks, or these solid bands of color of white and black shades, but it's a little too strong, it's a little too jarring. This might work for some art styles, but not for this that we're going for. We're gonna have to smoothen it out a little bit. So that's where, before we do this stuff down here, we're gonna quickly remap our values. So we're gonna create this remap node. Next in line. See, it's like a factory, right? You start with your inputs, your world inputs, you plug that all in and you get your output. So create a remap. Plug that in. And the way I set it up here is the input is this operation here. So we take our bands parameter, we're going to divide 1 by that shades parameter, and then plug that into the y value of a vector 2, and then plug that into remap. So we'll do it first and then I'll explain it after. So if I take bands here, drag out from bands, and then divide, you can see 2 options appear. You want to put divide B, because you're dividing 1 by bands. So you can see here, bands is connected to the bottom. Type in 1 on the divide here. And so now whenever you add more bands, it's gonna 1 divide by your band value. So if you do 4 bands, it's gonna be 0.25. If you do 3, it's 0.33, etc. And then from there, we're going to spacebar, vector 2. So vector 2 is just a x and y value. Think of, like, if you're looking at a graph, you have your x and y values, that's pretty much what a vector 2 is. And so you're going to plug this divide into the y value. So we're only affecting the second number, not the first number. And then you plug this into out min-max. Or, 1 second, just making sure. Into in min-max. So you're going to plug it into the top right here. Right? And then, real quick, we're going to set this x value in our out min-max to 0.3, like so. Just to kind of not have that black so sharp and dramatically dark. And then save. Right, so this is the setup here. I'm just going to close all these drop downs to make it easier to read it all at once. And so if you get stuck, you can copy this. Right, if you keep it all organized, it's easy to read. And so this result, if we check it now, this is what we're getting. And this is looking a lot like a toon shader from games we recognize. Mind you, not exactly as technical, but still a very promising result. You can see we have this shaded darker value here, this lighter gray value here, and this highlight white spot right here. Right? And once again, this is the code for that, the shader code. Right? And this parameter here, bands, I set it by default to 0.49. And you can see, if I go back into our scene, click on our toon shader material, there is an exposed parameter here that we can then slide to change the amount of bands we get. Isn't that so wonderful? You can just, if you hold control slower, you can just change the amount of bands you get, right? If you want to go for a higher look or a higher band count or lower. What we're going to do now is add a few more parameters to tweak how this looks. We are going to add two new float values. So let's call this one min. Another float value, max. Max, if I go back into my shader here, max, I want to set the default to 1. And then I want to set the min to 0.3. Right, so 1, 0.3. 1, 0.3. And then I'm going to drag those in. Boom, boom. Create spacebar, vector 2. And so that's pretty much taking our values here and combining them into one chunk of data called vector 2 that we can then plug into this single input right here, out min max. And what this allows us to do now is control the dark and highlight values within our editor here. So if I go back here, if I click on the toon ball again, there's min and max right here. This will change the dark values and the light values depending on what I tweak that to, right? And that's really good to fine tune your shader to look exactly the way you want it to. And possibly last, if we don't have time for the other step, is we're going to add some color variants that we like if we want to add. To do that, we're going to create one more float here, or one more, not float. We're going to create one color node, parameter node here. Keep that as color. So it's color. Drag that in here. And if we click on it here, we're going to, in the graph inspector, we're going to set that default to white. And one more node, multiply. This will pretty much take our shaded visuals and then multiply this color into it. Right? So save that asset. If we go back now, you're going to see that nothing changed, but we have this color parameter here. Now we can take that and change the color like so. See? And then now we have all these parameters that are exposed. We can tweak those to our heart's content. So I can make this a little brighter, change the highlight a little brighter as well. If I tweak bands, we'll get more or less. Right? And that's the result I think I like for now. Right? And that took 15 or so minutes to do, right? Not bad. Definitely more to work on from there to get things looking good in the scene altogether, but that's a basic toon shader that you can customize as well, right? And real quick, once again, I'll showcase this for all you to see. Normal vectors, main light direction, calculates our lighting values. We remap that between 0 and 1. We add the bands to it. We change the amount of dark and the strengths of the dark and light values, and then we add color into it. And that's our shader. Woo. I do not think we have time to do the cool noisy effects I mentioned earlier. Question?
You couldn't post the completed one in Discord, and then we could try to figure it out.
The screenshot of the full node?
Yeah.
Yes, I'll do that. So I'm gonna send a picture of, where did I put it again? Oh yeah, this one right here. And I'll have to also give you a texture, a noise texture that will be plugged into the sample texture 2D, and that will get you the look, that noise look you're going for. So I'm just gonna screenshot that. Put that in BC. And I'm thinking about releasing the shader after, like the shader package. I do want to see you all attempt to make it first, and then I will release the package for you to have the source file for you to try out. But let me just find, if I go to, where is it? Documents, projects. Here. This is the noise pattern I use to get that noisy look. So those are posted in the VC. You're more welcome to try that out. And that will be it for our practical component of our session. So round of applause again. Woo. So before we finish this session, we are going to have that raffle. Woo! Thank you, Sugbir. Anya, are you there?
Yeah, I'm here. I sent it in exec chat, but in case you don't want to stream exec chat, I can send it to you personally.
Sure. Let me just change the slide. Okay. Time for a raffle.
There you go.
Well, that's a good result. Yeah, I like that a lot. I like the blue you used. Here we go.
This year we only had 3 eligible entries.
Yeah.
Yippee!
Yeah, so
Wait, what's October?
Let's
Gactober,
go, gang.
it's also called OMAC. It's during the entire month of October, we have like a theme, and you create an art piece based on that theme. And it was 4 of them we had, right?
Oh, okay.
Yeah, and so that was during the week of October.
Yeah. The month.
Sorry?
The month of October.
The month, sorry, month. Yeah, sorry, month of October. It felt like a week.
You did really good.
So we're gonna now spin the wheel, and then whoever wins gets the $25 gift card of choice. So, can I get a little drum roll, please? David! Woo!
Well, yeah.
Go, David.
I'll hit David up. Actually, I can just text him.
Okay. I feel like I inside.
Sounds good. Well, congrats to you, David.
Did it come in?
Nice. Okay. Well, that is our session complete.
If you want to win,
Thank you for coming.
participate next year.
Yes, participate next year while you still can.
Yeah.
And thank you for coming. Shade on.
Yes.
Once again, please look at Shader Toy. Coolest website I've ever seen. It's like this is so cool. You can do this now. You can just look at cool shaders online and look at the code, right? And then look at NoClip. NoClip is so fun to fly around and see how older games they did their graphics. So please, if you want to take something away, these 2 websites are, and also Acerola on YouTube. Those are the The resources I highly recommend. I'll post the slides after as well, like a link to them. And yeah, thank you so much, everyone. GAC is over.
Do we not get
Dave, you wanted to use your